so I can see everything that's going on. Well, so I hope you've been enjoying Data Bash so far today. I think this is now the third Data Bash, so it's really great. It's a perfect time of year as well. After summer holidays, kids have gone back to school, and we can get back to some proper learning. So welcome to my session, and we're going to be attempting to look at a platform from a specific viewpoint. So we're going to look at a platform from the database administrator perspective. I'm just going to hold on for 1 second. There we go. So we're going to look at it from the perspective of the database administrator. Now, it doesn't necessarily mean that you have to be a database administrator. This is more about understanding that sometimes things aren't magic and you do need to look after them. And that's the case here with Microsoft Fabric. So we're looking at the warehouse service itself. So a little bit about me. That QR code will take you to my link tree. And from there's my company blog, my personal blog, my YouTube channel. But I work predominantly with the Azure Data Platform services. I'm independent. And I've worked with Microsoft technology for 20 years now, well over 20 years in the data space. So if you could imagine back in the 2000s, it's the traditional MS BI stack, SQL Server analysis services, so on and so forth. More predominantly in the 2010s into cloud. I actually started doing AWS before Azure. Azure started to come into its own, I think, in about the mid 2010s, so about 2015 onwards, really, when I started to use Azure SQL Data Warehouse or dedicated SQL pools. So firstly, massive thank you to the organisers. Look, this is a community-focused conference. It's free. So everyone that you see here has taken their time to not only create the conference, curate the sessions, monitor everything that's required to run these conferences that, me as a speaker, I could just turn up and speak, and you as attendees, you can watch and learn a whole bunch of things across. So massive thank you to sponsor and the organisers. So when we're looking at aspects of the Fabric data warehouse that might be relevant to the role of a database administrator, and these are the things that I've put together based on understanding the things that might be most important to a DBA. Between you and me, I was a DBA many years ago for probably a couple of years. And that was back in the early 2000s. And I was administrating Azure SQL. I was administrating SQL Server 2000 before I got into the world of data warehousing and development. So I like to think I have empathy. And I'm not just going to bring a server to its knees, that I will help my fellow DBA. So we're going to look at the compute itself, the Fabric compute and the SQL engine. The connectivity. So it's a cloud warehouse. How do we get to it? How do we connect to it? What are we going to use? What do we see? Storage. So as any DBA knows, storage is an incredibly important aspect. How do you set up storage? Are we in the world of being able to configure storage like we normally do? Yep.
Your camera seems still frozen again.
Okay.
Maybe your screen as well. No, the screen's working okay.
The screen's working okay.
You can go to the screen if you like.
Yeah, okay. So what I'll do is let me just try one thing with the camera, where I'm just going to change it into a different port. Okay. So let's see if I can start the camera up again. Okay, I think you can see the camera. So let's go back there. Thanks, Charlie. I think it froze USB 3. Okay, so if everything's okay, we'll carry on. So storage. Yes, the world of the DBA. We'd be involved in setting up storage, RAID, configuring RAID arrays on disks. What are we doing here? What about looking at the system itself? Do we have any way of looking at who is connected? What aspects of Fabric Warehouse do we have that we can look at and see how many people are connected? That kind of thing. So we'll look at that with metadata and DMVs. Transactions. Being many a developer who's brought down a server with some errant transactions, what do we have in terms of options here? What isolation levels do we have? How can we help developers better write their queries? Security. How do we lock down the warehouse? With this service in Fabric, there's a couple of caveats to be aware of when we're applying security. How do we see what's going on? We look at a platform like SQL Server. It has many ways of monitoring, many well-established third-party tools to monitor SQL Server. We've had these for decades, and they are fantastic tools. What do we have here? What can we do here? What happens when things go wrong? So we'll look at a bit of disaster recovery and source control. Okay, this might be a little bit of a Venn diagram with developers, but how are we linking this into a source control system? What source control systems are available to us? How do we deploy? Developers are like, well, I've done my thing. Can you get it live now? And we'll look at some performance tuning or some things, some aspects of Fabric Warehouse that we need to look at to be aware of. So what I want to do is set the scene a little bit. So it's Friday, it's late afternoon. Obviously we've had a code freeze for the day, so nothing is being deployed. And we're ready to leave the office. Oh, we get a WhatsApp, we get text. That person with no planning ability has messaged you, the DBA, to say, hey, look, we've got this new thing. You have to look after it. Okay, sorry, I've just seen this. I'm about to leave the office now, so maybe I'll check it out in a bit. But I see Fabric Warehouse, and I think, well, okay, so what's a Fabric Warehouse, and why do I now need to look after it? And that person with no planning says, well, hey, it's going to solve all our problems. Yeah, no problem at all. Yeah, we're gonna migrate. We're going to do these amazing things in the cloud. So with a bit of a weary sigh, us as DBAs or our local DBA friend might say, okay, you know what? Let me have a look at it then. Let me solve the problem for you. So let's have a look at Fabric very quickly. When Microsoft created Synapse Analytics, which was the cloud analytical system, they built a new studio or a web app and brought some Power BI functionality into it. I don't think I ever really saw many people use that Power BI functionality, to be quite honest. So what Microsoft have done here is moved SQL computing, Spark, there's real-time streaming, into a more familiar world of Power BI interface, more familiar to people who use the reports themselves, people who build reports, people who build data models, maybe less so for data engineers, maybe less so for DBAs, database administrators. Okay, so the first thing is it's moved into, and I like the GUI of Power BI, but it has moved into the world of Power BI. We're not really purchasing servers. We're purchasing what's called a capacity. We'll look at that in a little while. One thing to note is that a lot of the control is abstracted, away from us. Spark configuration we can do. We can create clusters, size of clusters, auto-scaling policies. Fabric Warehouse, less so. The biggest departure in terms of storage is that it's all now underpinned by Delta format. And this logical concept of one lake, which is essentially Azure Data Lake Gen 2. So we're not having to configure disks, we're not having to configure storage. This is all managed for us in Fabric. So we're not even responsible for creating Azure storage accounts and linking to Fabric. It's all part of the platform. So again, why would that person text you and say, well, we've got Fabric now, we've got a Fabric Warehouse, and you think, okay, well, why would you want to do that? So with Fabric, we're really looking at building an end-to-end data platform solution. We've got a bunch of source data, APIs, relational databases, third-party services, file systems. With Fabric, we've got the services there to connect and ingest that data. We can process that data. We've got notebooks, data flows, T-SQL. We can store that data. We've got different storage methods, lakehouses, warehouses, real-time streaming databases. Ultimately, why are we doing all of this? Well, we want to push some reporting downstream. Maybe we want to do some of that funky artificial intelligence and machine learning. Ultimately, Fabric is a software as a service platform, which essentially means that Microsoft are looking after the compute for you. They're looking after the service. They're keeping it running. They're keeping it patched. They're maintaining it. You don't have to worry about having to take the service down for maintenance. It's all being done for you. However, you are responsible for the data. So whatever data you're ingesting into Fabric, well, that's your responsibility. As is security. Various options within Fabric to do with security. But ultimately, we're on that left-hand side in terms of software as a service. Microsoft are looking after all of the physical side of things and the software side of things for you. You're just looking after the data. So in terms of the warehouse service itself, yes, it's T-SQL software as a service. We're not having to install SQL Server. We're not having to provision any form of Azure SQL database compute or dedicated SQL pools compute. It's there for us when we enable Fabric. So this concept of serverless, there's always servers, right? There's always servers, but from our perspective, we see it as serverless because we don't have any servers to manage. Great news. There's automatic maintenance, behind the scenes in the Fabric Warehouse as well. But the interface is going to be very familiar to anyone with any SQL experience. Creating tables. You've got columns, you've got data types, stored procedures, views, functions, all the familiar T-SQL and relational database constructs. There's limitations because this is doing a very specific thing. This is for analytics, it's for data warehousing. It's not really for your row-by-row transactional system processing. And it does now truly separate storage and compute. The warehouse service itself is a little bit more of a closed system. So the way that it works with storage is not really that accessible to services outside of the warehouse, other than to read the data. So we can't modify data outside of the warehouse service. But the storage is what you would consider open source. We're using Delta Lake, which is based on Parquet. So as a DBA, you're looking at the data and the structures and the logs, but they're stored within files. Those files are going to be stored somewhere on a system. It's not like I like to think of Parquet files as the MDF and LDF files within SQL Server, but Parquet files hold a lot of information. They hold the data itself, the structure of the data, they hold statistics. Just like an MDF file for SQL Server would hold all of that. Delta itself then adds the logging ability. Hey, well, that's an LDF. And we have transactional consistency. There's been some arguments that it's not really full ACID, right? And maybe we'll look at we're going to look at the transaction aspect in a bit. But we have the ability to read and write data and ensure that that reading and writing aren't blocking each other. And more importantly, is committed and isn't corrupt and isn't left in an unusable state. So in terms of what are we using the warehouse for? Well, it's for the right-hand side if you're going from left to right in your data flow. Is it for raw data? Probably not. Is it for cleansed data? Maybe. Is it for facts and dimensions? Definitely. So that's where you want to be putting your cleansed data that you've modeled. Think dimensional model. Now, I'm just going to pick dimensional modeling as a data warehousing methodology. Other methodologies are available, but you will have to look into whether the warehouse is suitable for that. But if someone's asking you to look after a fabric warehouse, have an eye on the fact that it's going to be a warehouse, a data warehouse you're looking after, not a line of business application, row by row inserts. Well, I think after 17 minutes, it's 18 minutes past the hour. It's all magic, right? It's all done because it's all in the cloud. So no one has to look after it. No one has to be mindful of any considerations. Microsoft takes care of everything. So yeah, I think that's it. I think that's 42 minutes left. Except it's not quite magic. There are some considerations. So the first thing is all about the fabric compute. Well, what's running compute? So we can go into, someone can go into the Fabric / Power BI admin portal, click the button that says let people use Fabric, allow Fabric workloads. Oh, fantastic, brilliant. Okay, well, what do we need to actually run it? So there is compute. You do need to provision compute. That compute is provisioned within Azure, and there are various tiers of compute, starting all the way from an F2 SKU, scaling all the way up to about an F2048, I think the maximum is. I think you have to ask Microsoft if you want to provision an F SKU that much, and you probably need to get out quite a few credit cards to be running that sort of SKU. But if someone's coming and saying, well, how do we use Fabric? Well, just as you'd be buying hardware and installing SQL Server or any other relational database on that hardware, you're going to have to provision compute. You're going to have to go into Azure and say, right, I would like a Fabric SKU. It's going to be this size. Start. Then you can start assigning your workspaces within Power BI to those SKUs. Now, a single Power BI tenant supports multiple SKUs because a capacity is region bound. So if we create a capacity in UK South, the data is going to be stored in UK South. If we create a capacity in America, Data is going to be stored in one of the regions in America. Yes, capacity planning. We do have to make sure that we're going to be provisioning compute that is going to meet our workload expectations. So when you're buying a server, you're not just going to close your eyes, pick a server size and hope it's going to work. You're going to be saying, right, well, I need 16 cores, or I need 32 cores, or 64 cores. I need 128 gig of RAM. I need a terabyte of RAM. These are all the considerations that you need to go through when you're doing your capacity planning for any other system. And it's the same here. But a couple of the concepts don't really have a lot of time to go into are called bursting and smoothing, where for periods of time, if any of your workloads need more resources than your current capacity can handle, your capacity will burst beyond its means. You are essentially borrowing from future compute. That's the smoothing aspect. So you can't burst all the time. Otherwise, you're going to get penalized. You'll get throttled and you'll get charged for it. However, when we're looking at these workloads, if we were provisioning a server, or we're buying hardware, or even provisioning a server in Azure or one of the platform as a services, we're going to have to provision our service to meet the demands of that tallest spike, that spike that's reached about 150, 160. But otherwise, our workloads are going to fail. Fabric, on the other hand, it's more of a smoothing out of the workloads. So we don't really have to care too much about the spiky workloads, because, or more accurately, we do care about the spiky workloads. We just don't want too many of them. Otherwise, it's going to affect the capacity's ability to smooth out that workload. So when you're looking at your workloads, understanding when data loading processes are happening, this is what you're going to be looking at. But if we're going to put a hard value in terms of what these capacity units mean, so for the warehouse service specifically, even though the documentation talks about 1 CU equals half a core, well, I can't provision a capacity that's only 1 CU. I've essentially made it so that 1 core, 1 virtual core, equals 2 capacity units. So for example, if you were to provision an F64, that's going to give you 32 cores, or the equivalent of 32 cores for the warehouse service. But of course, that capacity will be shared by any other workloads in workspaces that you've assigned to the capacity. So think about not just the warehouse service itself, but also the other services, pipelines, notebooks, semantic models and reports, so on and so forth. So with the bursting, Microsoft are giving you extra compute. However, with the warehouse service, there are guardrails. It's not just going to burst to infinity and give you a massive either throttling or bill headache further down the line. You've got some scaling factors. So, for example, if we were, to look at that F32, it gives you a 12 times scaling factor, right? So it's going to take you up to a much higher SKU for the duration of the bursting, or that's its maximum that it'll take you up to. After F8, the scaling factors are the same. So you're going to get 12 times that scaling factor. I can only imagine how much compute is if you scale up from an F2048. But all of this is automatic. You don't have to do anything here. But you do have to monitor. We'll come on to that in a little bit. Now, in terms of ingestion and querying, the Fabric Warehouse, it has a concept of workload isolation, where a warehouse will isolate its ingestion processes from its querying processes so that they don't affect each other. So the guardrails actually apply independently for ingestion and querying. So it's not all just lumped into one thing. So in terms of the SQL engine, so I'm just going to bring it all up here. This is the world of distributed computing. So all the things you know about on-premises SQL servers, they apply somewhat here. And there is SQL Server within Fabric SQL, but the journey started, over 20 years ago. Microsoft purchased a company, Datalegro, and its technology, wrapped it in a bit of SQL Server love. We end up with the parallel data warehouse and the analytics platform system. Microsoft then Azurified it, put it in Azure and made that, and we got Azure SQL Data Warehouse Generation 1 and then Generation 2. Generation 2 is what we have in Synapse Analytics with a new service that Microsoft created based on a new engine, Polaris, Serverless SQL pools. That's the engine that we have in Fabric SQL. So it shares some heritage with SQL Server, but its architecture is different. So I'm not going to dwell too much. Obviously, I'll make the slides available afterwards. But really on the right-hand side on the Fabric Warehouse, look, we're not installing anything. We've really got no control. It's all auto-scaling behind the scenes for us based on the query and the workload demands. At the moment, we can't partition any tables. At the moment, there's no indexes. The data itself is the index. The Parquet files are column store compressed files. So it's like creating a table in SQL Server and applying a column store index. That's what those Parquet files are. So there's no non-clustered indexes on tables, for example. And we don't have the full range of isolation levels because really that warehouse is designed for loading and for loading data for warehousing and then reading. So we don't have to have all those fine-grained isolation levels that transactional systems need to have. We've got an isolation level that is standard across Delta and a lot of the cloud, let's say, ACID compliant services that work with file formats like Parquet. So we've got Delta, we've got Iceberg, we've got Hudi. By and large, they have a minimal set of isolation levels. So when we're connecting to this magical Fabric Warehouse system, well, firstly, we're creating objects. Okay, yes, we can create objects, or rather Fabric items programmatically. We can use the API. Interestingly enough, the Fabric Terraform module has just been released. It's very beta at the moment, but if you like to wrap up all your infrastructure into code, Terraform is going to be there to support how you would do that within Fabric. Want to manage how to deploy your warehouses and pipelines and notebooks? The Terraform provider is going to help. Ultimately, when we look in a workspace, well, we've got a whole bunch of items. And obviously with Fabric, we've got a lot of items that we can deploy. Really, if we go to one of the common tools that's used in SQL Server, which is SQL Server Management Studio, well, we can see warehouses as if they were databases. When you create a warehouse in a workspace, really what you're doing is you're creating a database on a server. A workspace is in effect a server. We can connect to it using database projects in Azure Data Studio. So common tooling that we use. Every warehouse and Lakehouse SQL endpoint within a workspace exposes a SQL endpoint. The thing is, the SQL endpoint, it's the same for the top level workspace. When you connect in your client tool to your Fabric workspace using the SQL endpoint, you're going to see the warehouses and the Lakehouse SQL endpoint as databases. It's going to enumerate as databases. So whenever I'm looking at the endless discussion in forums about, well, how many workspaces should you set up and where should you put your services, I always think about the fact that, okay, I'm looking at a workspace almost like a server. If I'm going to look after a workspace, I'm almost going to look after it like I'm looking after an individual server. But when we create workspaces, those workspaces are connected to a capacity. So you can have 10 workspaces which look like 10 servers, but they're all running on the same capacity. So with storage, now, this is an area in which up front, I'll say we don't have an awful lot of control over. So we're using Delta. Microsoft chose Delta. Delta is what is providing that transactional capability. That's what's ensuring that when you're reading and writing to these Parquet files, there's no corruption when you're writing, that everything is left in a consistent state, adhering to ACID principles. Atomicity, consistency, isolation, and durability, making sure that when you're writing data, it's not becoming corrupt. And also when you're reading it, you're not going to read uncommitted data. However, with this storage, there comes some issues with it. Parquet files are essentially immutable. Once you've written a Parquet file, that's it. You can't go back to an individual Parquet file and update some of the rows or delete some of the rows or insert some new rows. So what Delta is doing, it's managing how those Parquet files are being written. If you're constantly writing small updates to the warehouse, what's going to happen is you're going to get lots and lots of smaller Parquet files being created behind the scenes. So if I do an insert and then another insert and then another insert, more likely I'm going to have multiple Parquet files under the hood. Now, lots and lots and lots of small Parquet files are not really very good for reading, because whatever engine is reading those Parquet files, it has to enumerate the Parquet files, it has to crack them open, look at the metadata, and read them. There are options, and these are standard options with Delta tables, so Databricks, Lakehouses in Fabric. We can optimize and vacuum. Optimize is all about hoovering up lots of small files and creating a fewer larger files. Yep. Column store compression, which means we're going to get a lot of compression into the files, obviously depending on the cardinality of the column. But that's going to make read performance a lot faster. We can't control any of that. We can't set or trigger any form of optimization. The warehouse is doing it behind the scenes. It is looking at your querying. So it's not just doing this for every single table. Based on the queries that you're running against your warehouse, the warehouse service will think, okay, so you're using these tables quite a lot. Tell you what, I'm going to go and optimize them. So it will go and either rewrite the data to optimize the Parquet files. And vacuuming is essentially just removing old data once these new Parquet files have been written. So at the moment, I believe the 7-day sort of vacuuming period has been increased to 31 days. But this is all automatic. You have no control over any of this. And we'll talk about the V ordering later on in the performance analysis. So with metadata and DMVs, well, there's a cut down number of DMVs. So we don't have the full range of DMVs that we would have with SQL Server or Azure SQL Database or dedicated SQL pools. And to be honest, it makes sense because of the whole bunch of DMVs that are just not relevant here. So for example, you're not going to need any DMVs related to files, or sorry, related to MDF and LDF files and things like this. But we've got connections, right? So we can look at DM exec connections. We can see who's connected, the client address that we're coming, the authentication method. We've got sessions. So we can see number of active requests and the status of those requests. And, well, exec requests as well. So if we've got any queries that are currently being executed, we can see those in the DMVs as well. Now, you as the DBA, you do have, well, if you've got permissions, which you should have, if you are a Workspace or Power BI / Fabric Workspace admin, then you're going to be able to see all of these DMVs. And more importantly, if there's anyone who's run something that's clogging up the system, we've got the option to kill the session. Now, everything is magic, except when it's not. We do have to look out for how we're writing data into the warehouse, because we still have transactional capability, we still have isolation levels. Okay, now a big thing is said around the differences between lake houses and warehouses and which should you use, and Microsoft have a table to tell you if you're going to be doing this, the lake house, if you're going to be doing this, the warehouse. So at the moment we have these two objects to choose from. One of the aspects that Microsoft call out is the fact that you've got this multi-table transaction support. So if you're trying to read and write to multiple tables and you need that consistency across those tables, then we can wrap multiple table workloads into a transaction statement. The fact that we've got snapshot isolation is the only isolation level supported, it kind of makes sense because we're using Delta, and that's essentially the isolation level available for Delta, which is the most optimistic of the concurrencies. I mean, if you have a favorite isolation level, for me as predominantly a data warehouse developer, yeah, I like snapshot, right? Because I can query data as I'm loading it. Things aren't gonna lock each other. However, at the moment, the locks are at the table level. So what this means is that statements can affect each other. Now, insert statements, there's far less chance of locking becoming an issue because Parquet files are immutable. Inserts are always going to go into their respective Parquet files. Metadata will be updated. So I don't see many issues with multiple concurrent insert sessions into the warehouse. Where I find the trouble is updates and deletes. Updates and deletes are the process is like a kind of a first past the post. If I issue an update statement and then 5 minutes later, whilst that update statement is running, my colleague also runs an update statement. If my colleague's update statement finishes first, my one gets kicked out. And it's the same with deletes. I see it quite a lot on forums. People post the error message to say, I can't quite remember the exact error message, but it's, this transaction has failed because it can't access the table. So it's something to be aware of. But you can see the locks, right? We've got the DMVs to show the locks. And there are really only a handful of lock types that we're going to see. If we're selecting data, we're going to see a schema stability because we don't want the table schema to be changing while we're reading that data. On the table level, we're going to see intent exclusive. Inserts, like I said, I don't see too many problems with concurrent inserts. But deletes and updates, you're going to see some problems if multiple statements are hitting the warehouse at the same time. And yeah, a table is going to have a schema modification lock if you're doing any form of modification on the table. We're limited in terms of what we can do with schema modifications on the table. We can only really add primary keys, unique keys, and foreign keys, which are not enforced, or we can add a new column. We can't change the data type. We can't drop columns. So I find this less of an issue. So in terms of security and permissions, so this is where I said earlier, we got a couple of caveats. And again, I see a couple of questions on forums about this. Now, what's one of the most common duties that a DBA performs? Access. Hello, friendly DBA. I would like access to that lovely production server. Well, okay, let's discuss it. But doesn't matter whether you've got workspaces dedicated to dev or test, UAT or production, we're going to need to set up security. And it's multi-level. It's not just at the warehouse. Other levels of security are going to affect how this happens. So essentially, we look at the workspace level. So these are roles that have existed for many years within Power BI. We can be an admin of that workspace, i.e. we've got full control over that workspace. We can be a member, we can be a contributor, we can be a viewer, right? Those permissions allow you to do certain things with certain objects within Fabric. From the warehouse perspective, if you're given any of these permissions, it has a drastic effect on what you can and can't do within the warehouse. I'll come back to that when we look at the SQL Granular permissions. So yes, by all means, if you have warehouses in workspaces, set these permissions. However, if you set someone as an admin, a member, or a contributor, they get control permissions on the warehouse. Quite high level. In fact, very high level. If you add them as a viewer, they get added as a data reader. They can read all the data within the warehouse. Not particularly granular. So let's say we've got a couple of items or a couple of warehouses in our workspace. What we can do is we can share the warehouse. That's initiating the permissions process here. Again, one of the common things I see is when the share pop-up appears, you've got some checkboxes and you can say, right, I'd like to, actually, I'm going to bring them all up here. I can read all data using SQL, so a DB data reader. I can read all data using Spark, i.e. I can get in to the files that underpin the warehouse themselves and can build reports, right? So if I'm a BI developer and an analyst, I'm going to be able to be given permissions to build reports. However, there is another permission that you can set when you do this sharing process, and that is no permissions at all. You click on share, up comes the pop-up, everything is unchecked, is deselected, and you share with the user or the group. What that does is that gives them connect permissions. It does not give them permissions to do anything else. You then have to go in and you do the granular permissions on the objects. Now, this is important with workspaces because if we use constructs like row level security and column level security, we can do the necessary grant. So grant select on, this table and these columns. I'm initiating, to such and such. So I'm initiating column level security. As soon as I were to apply a workspace permission, that completely overrides all of the row and column level security. So one to be aware of there. Now, in terms of monitoring, okay, yeah, everything's been magic so far. We haven't had to do an awful lot. Our capacity will be consumed by multiple services. So what Microsoft provide is an out-of-the-box report that tells you per service, per workspace, what's going on, how much of the capacity is being consumed by these items. So you can see pipelines, notebooks, the warehouse itself. So with the warehouse, you're going to see reads and writes. I'm just going to bring up the fact that with Lakehouse SQL endpoint queries, they're reads. So you will see those in SQL endpoint query. But ultimately, what I'm interested in as the DBA, I'm interested in that CU. I'm interested in how many capacity units did that particular workload take, because I need to then make sure that that workload is not overrunning the capacity. At the moment, we don't really have much control over workloads within a capacity. So I'm interested in how many capacity units, how many total capacity units are my workloads taking, or other people's workloads taking, right? And we've got some OneLake stats in there in terms of reads and writes for the data. Now with Query Insights, this is a warehouse specific functionality. So when you create a warehouse, you're going to get this Query Insights schema. And we've got 4 very important views in this schema. We've got the requests history, right? So it's going to show us, and I've got this note at the end, but I'm going to say it up front now. We've really only got 30 days or 31 days of history in these Query Insights table. If you want to store it for a longer period of time, use T-SQL, load it out of Query Insights and merge it downstream with something. The 2 that I use a lot are the long-running queries and the frequently run queries. Every single Query Insights view has the SQL command. So you're not going to have to join onto something like, well, now I'm being tested, sys.dm text, something like that, that brings back the actual command that was run. That isn't even supported within the Fabric Warehouse. The command is a column within all of these views. So if you need to pinpoint specific queries that are run, it's all there for you. The frequently run queries, that's the one that I look at the most because it has statistics around the average time it took for a query to run, the minimum and the maximum. What's clever is what the Fabric Warehouse is doing is when it receives a SQL query, if it has seen that SQL query before, it's going to add it to these statistics. So for example, if a query's been run 5 times, it's going to take those 5 runs and compute your statistics for you. So the average is probably important to track over time, in case any queries are starting to creep up in terms of their average time that they're running. You might be able to head off a potential performance issue if you're tracking these queries over time. Now, I am working on something, and I'm hoping to get it onto GitHub pretty soon, which merges the world of the Fabric capacity metrics with the world of the query insights, because we've got a common key that we can use. In the world of the capacity metrics app, it's called the workload ID. In the world of query insights, it's called the distributed request ID. That's the ID that you would give to Microsoft to do it. But what we can do is we can join an actual SQL query to the capacity units that used. We can't do that in query insights, but we can merge the two worlds together. And the reason I want to do that is because I can actually do some cost calculations. So let's have some fun and do a cost calculation here. Now, the metrics app, it's going to show you the total capacity units that a workload used. I'm going to take an example. Let's pick an F2. Now, the pay-as-you-go pricing at the moment for an F2 is 31 pence per hour. I go into my Fabric Capacity Metrics app, and I've seen that a particular warehouse workload for a given day has used a total of 8,000 CUs. How do I equate that to an actual dollar or pound or euro pricing? It may be that we're able to charge different departments for our usage. That's the goal. That's the end. That's the dream, right? So, because these are capacity units a second, what an F2 really means is you're getting 2 capacity units per second. We do our calculations. So every hour, we're allowed to consume 7,200 capacity units. I'm not going to go into bursting or smoothing at this point, but that's what we're paying for, right? So if I do a calculation based on how much the capacity units are per hour, I can get to a price of, 0.159 per CU. So I'm going to do that calculation. And that's, by the way, that's not a pence. That's less than a pence. It's 0.15 of a pence. So I'm going to do my calculation. I'm going to say 8,000 times 0.159 divided by the number of seconds there are in the hour. I get my total price. Now that, if you eyeball it, that kind of looks right. I'm paying 31.8 pence per hour for 7,200 CUs. My workload has actually used 8,000 CUs. So yeah, 35 pence, a little bit more. But that's how you can work out how much each workload is costing. And the thing is, this calculation is going to work across the different SKU sizes as well, because the prices are scaled linearly. Now, with disaster recovery, a bit tricky here. So we've got restore in place, right? So we can restore a warehouse, just like we could do with dedicated SQL pools. Microsoft are just making these checkpoints behind the scenes, or these recovery points that you can restore to. So if anything happens to your warehouse, you can restore to a previously good known state. The only problem is it's the whole warehouse. It's not piecemeal restore. We can't do individual tables. Really annoying right at the moment. But the restore points, we've got automatic restore points. So we don't have to do anything. And I think that actually the days available has now increased to 31 days. But essentially, Microsoft are creating these restore points for you. However, you can do those yourself. So you can initiate manual restore points. So if you're told about a big deployment that's coming up, or a substantial data load, it might be worthwhile before that happens. Let's do a restore point. Let's create a manual restore point where we can sort everything out afterwards. Workspaces, if you delete a workspace, it can be restored. Warehouses, if you delete a warehouse, can't be restored. And we'll just finish up. So source control, we can integrate the whole workspace in Power BI/Fabric into Azure DevOps or GitHub. So all the items are going to be source controlled. We can do that though with Azure Data Studio. So if you use another Git provider, use Azure Data Studio with SQL database projects, and you're going to be able to source control. And we've got the option to use deployment pipelines to push those changes across workspaces. The problem is that if you do any form of modification with tables, be prepared for the table to be dropped and recreated. It can delete the data as well. And the last thing we'll look at is performance tuning. Yes, you can create statistics. There's manual statistics being created. There's histogram statistics. You can create manual statistics yourself. Unfortunately, you're constrained with using single column statistics at the moment. You can enable and disable V-ordering. V-ordering is Microsoft's special sauce to enhance the performance of Power BI semantic models when querying data directly in the data lake. We may want to disable this V-ordering if we're doing a lot of write operations in the warehouse, because it's very write intensive. So it's an increased amount of time and capacity units when V-ordering is enabled. Like we said, look, you come in at the warehouse service and you're using it as a warehousing service. Little trickle loads, they don't really work here. And there's a warehouse performance guidelines document for you to go through and make sure that all those pesky developers and pesky data warehouse developers are adhering to some performance best practices as well. So I think with that, I'm going to hand back. Thank you very much. Thank you to DataBash. Thank you for listening. I hope it's been helpful, and I'll make the slides available on social media.
I think I'm on mute. Thank you very much, Andy. How are you doing? Thank you very much for that. It was a great session. I was watching it intently as a DBA myself. So thanks a lot for the effort of putting that together. And
let's have a conversation, Charlie, at some point, because
great, let's do that.
It's quite empathy towards the DBA, and to make sure that that DBAs know that unfortunately there is a role for you, very much so, within the world of fabric warehousing.
100%. There's still work to do, isn't there? Always.
Yes.
Oh.
Yeah.